Now, in the last video, we went through and looked at this problem on the right, and it was really just a recap of how we can use the binomial probability formula to work out probabilities. Of course, what you may remember is that we can do things far simpler by using our calculator. That's not to say that we shouldn't be able to know and use this formula, but our calculator is there to do the calculations for us. Now, this problem, again, can be summarised, rather than writing out this worded problem, in this way, because this is a binomial distribution problem, and this is saying that we can work out probabilities of our values of x using a binomial distribution where n is 10, so our first value here is n, and we were doing 10 trials here, and the probability that we got pink, so pink was our success in this case, was a quarter. And so this is the kind of notation we might just use. Rather than writing out this long problem, we might just write it or pose the problem in this way. So find the probability that x is 3. Find the probability that we get 3 successes or 3 pinks. Well, we've already done that. We know the answer. This is what we did here. But we're going to use our calculator in a much more efficient way, and I'm going to give you a reminder on how to do that. If we want to find just a fixed value here for the amount of successes, then we can use our binomial probability distribution on our calculator. To get there, we just need to press menu, number 7, and then number 4 here, binomial PD, probability distribution. And the easiest thing here to do is press number 2, variable. And we're just asked for 3 values, and that's all we need to tell our calculator. Now, in the formula, we do use R for successes. Here, we just use the letter X, because we want X is 3. We're saying X is 3 here, that's our variable. So, we want 3 successes. N trials is 10. It's a capital on our calculator, but it's the same thing. And P, the probability of success, is 0.25 or a quarter. You can put in a quarter, you can still put in a fraction, okay? When you do, it won't actually give you the numerator and denominator in this form. It will just put this fraction notation. So that's 1/4, or you can just put 0.25. We don't need to put in Q because, of course, Q is 1 minus P. The calculator knows that. And if we press equals, turns it to 0.25, we get the answer 0.250. So that is a value that we already knew because we had calculated it with our formula here. So if we want to work out a fixed amount of successes, that's how we can do it. Now, if we want to work this kind of thing out, so probability that x is less than or equal to 7. So the amount of pinks we get is 7 or below. So anywhere between 0 pinks and 7 pinks. Now we could work out all those probabilities individually and add them up, but we don't need to do that. We can do that on our calculator. So just going back to the menu, just so you can see where this comes from. It's number 7, distribution again. And this time we need to use the down arrow and go to binomial CD. C stands for cumulative because this essentially is adding probabilities. We need to add the probability that we get 0 pinks, 1 pink, 2 pink, all the way up to 7 pinks. So binomial CD. And again, I'm just going to choose variable. Now, the numbers that I'd put in before are already there, but this is what we now want to put in. We will now put 7. This is not going to calculate the probability of getting exactly 7 successes because we're on CD. By putting in 7, it will calculate this, the probability that we get 7 or below. So this is going to add the probabilities up for us. We don't need to change our N or P because they're the same as before. And we can just press equals and we get this answer here. So I'm going to write this to 4 significant figures. So 0.9996 to 4 significant figures. Because it's very likely, isn't it? It's very, very likely that we would get 7 or fewer pinks. Now, what about when we've got inequalities that aren't quite the way we want them? So what's the probability that we get greater than 5 pinks? Now, if we remember here, this binomial cumulative distribution takes the value put in and below. So we really need to think here that if we want to work out the probability of getting more than 5 pinks, then that will be 1 take away the probability of getting 5 or below. Because we're either going to get more than 5 or we're going to get 5 or below. So this is what we can use our calculator to work out. So we can go back. You can just press the option button there. It's a little bit short, or you can just go back to menu. We can go back to cumulative distribution variable and put in 5. Now remember, this number will give us 5 and below. So we will need to subtract that from 1. So again, normally a good idea to write down to 4 significant figures here, particularly, or even more, particularly if we're subtracting. Because now we can go back to our normal menu and do a subtraction. And now we know when we round this, we've not got any errors. So again, I could still now round this to 3 significant figures, which is what we'd normally give our final answer to. Now, being a bit careful here, 3 significant figures would be 0.0197. Now for D, we've got a double inequality here, if you like. But again, we just need to think very carefully about what this means. This means that we want to work out the probability of getting somewhere between 7 or fewer pinks, okay, but more than 3. So again, how can we use our cumulative distribution here? Well, we can easily work out fewer than 7. In fact, we've already done that up there, haven't we? But I'm going to write it again. So the probability that we get 7 or under. But that would give us the probability of getting 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. And we don't want to include those bottom values because we want to get more than 3. So we need to take out the 3, the 2, the 1, the 0. So we can do that by subtracting the probability of getting less than or equal to 3. This is less than or equal to 7. We take away less than or equal to 3. So we're just left with the 7, the 6, the 5 and the 4. And those are the values in this inequality. So I already know this one because I've written it down here. So 0.9996. And I'm just going to go back and work out the probability of being 3 or below. And that is 0.7759. So our final answer for this one, again, to 3 significant figures, is 0.224.